Hello Internet people, welcome to more Haskell live coding, where I try and learn some Haskell and share it. I'm going to take a little break for next month from the normal writing projects I was doing, so I'm going to stop for a bit on megaparsec and also on Servant. I'll come back to them in January, but I thought, given that there's Advent of Code happening right now, and I'm trying to find time to do it anyway during the day, might as well combine it. So what I'm going to do tonight is do the second part of the Element of Code, because we're in day 2. I haven't looked at this yet, so I'll be doing it like totally live. I gather it's quite straightforward though. I think like the first few generally are quite easy to do, so I don't know how long it'll take. Perhaps if it doesn't take very long at all, and we have a lot of time left, I might look at trying to sort of automate some of the Element of Code stuff, maybe to write a script that's kind of creates a skeleton for me to work from, maybe even grabs the file and the instructions, but that might be a little bit more involved. We'll see. But yeah, so that's the plan for today. So what I'm going to do is, I guess click this and we can have a look at the Element of Code website and read what it's all about. Okay, many words as usual. So we have commands that we can send to our submarine. So go forward, down, or up. Okay. Down and up affect your depth. So, really? Because down would make depth higher, wouldn't it? So your submarine seems a already planned course. You should probably figure out where it's going. So you go forward 5, down 5, forward 8, up 3, down 8, forward 2. And you've got a horizontal and a depth position, okay, starting at 0. So forward 5 makes your horizontal position go forward 5, as you expect. Down 5 gives you a depth of 5, and then up 3 presumably gives you a depth of 2, yeah. And forward 8. And down 8 and forward 2. Okay. So after following these instructions, you would take a horizontal position of 15 and a depth of 10, and then you multiply them together for some reason. Okay. Then you calculate the horizontal position and depth you would have after following the planned course. What you get if you multiply your final horizontal position by your final depth. Okay, I've got the puzzle input in a moment, but I'm going to start with this test input. And let's go and find this. Okay, cool. So, let's get started. Do it from here. Okay, so we're day 2, and actually let's start from there. And we go to /main.hs. Okay, module main, let's put main, where main has got type IO unit and main is undefined. And did I manage to copy the input properly? I did, cool. So we'll just make that a comment, oops, a comment. Okay, so we, because of the way this works normally, I think I normally have a skeleton, so we say interact, and then what we're going to do is, the function we're going to call, I'll just call solve, or maybe solve1, and it will return something which might not be a string. In this case, we're going to multiply numbers together, so it'll probably return an int. So we'll show it, call solve1, and we will read the input in. Well, that's what interact is going to do for us. So we'll split it by lines. And I think for this one, I'm not going to convert it into anything, so it'll come in as being a string. Okay, so that would suggest that solve. I'm going to it's going to take a list of strings and it's going to return some kind of int. So we just set this to 0 for a second. Oh, I call it sol1 because it's the first part. Okay, so we'll take some x's, some instructions. I'm just going to turn 0. It's just a skeleton. I'm just going to make sure this works. So in theory, if I say run Haskell, oh, I need to go into the directory 2. Let me save that. Oh, I've missed. I put it in the wrong place. Okay. 2/, let's move it to here. Let me close that, and then we can go main. Save that. Okay. Good start, wasn't it? So we go into 2. Yeah, the file is there now, cool. So I should be able to say run Haskell and main, and it should say 0. Okay, which is like not the right answer, but it's an answer. Okay, so we're going to feed into it this string, this list of lines, and it's going to move the thing around. So we're going to, I mean, I guess we could literally match on these words, couldn't we? We've got forward, down, and up. So if we say move, actually, let me just start by creating a position. Oops. Which is just going to be a pair of ints. I don't need a type constructor because I'm declaring it as a type. But I do want that. Okay, so the position is going to be a pair of ints, and our initial position will be 0, 0. Okay, so then we can say move, and that's going to take a single string, so a line from our input. Let's get rid of that for a second. And it's going to return, oh, we might as well take a position, an instruction, and we're going to return a new position. Hope this is the right way around. What I'm thinking here, sorry, this type signature, position, string, position, I want to match fold, and I think I probably want to match left fold. I think is the right way around. Let me see. The type of foldle, I think, is B to A to B, and then initial value B, and then a list of A's. The B to A to B, initial value B, a list of A's, in terms of B. So in this case, position is our B value. Our string comes from this list of strings, so that's the A value, and it returns a B. And we'll give it an initial position, which is a pair 0, 0. And then we will return a new position, which is cool. Okay. So move P and literally, oh, okay, so I don't actually want a string in this case. I actually want a direction and a value. Okay, so what did they call it in here? So they call it a command. Let's call it the same thing. Okay. So command, which is not going to be a type, it's going to be data command is going to be forward int or down and then int or up and then an int. So it won't take a string, it'll take a command. And then we can say if this is forward x And we might as well destructure this while we're at it. So this is going to be two ways of doing this. So I was thinking that I could destructure this. So I could take like an X or like a horizontal and a depth. And forward X, I would return a new position, which is horiz plus X, and then just the depth unmodified. Good mistake, wasn't it? Okay, so I thought I could do that. And that would be fine, but it's just like a bit messy, I think. What I might do instead is just turn P into a... I was going to say a semi-group, but actually if I turn it to monoid, then we'd be laughing, wouldn't we? Instance position the constraint, but as a kind. Okay, got it right. So monoid position. I always get this wrong. So to implement type class, it's is it a bit round? Is it that straightforward? No. Expected start to constraint, but position has kind star. I don't know. Oh, I can't do it on the type. Oh, okay. New type position is position blah. Okay, cool. So it's just I couldn't declare an instance on a type because a type gets removed at compile time. I think like it's just a type alias. It just gets literally substituted. Whereas new type, I can at least declare as being a type class or implementing a type class. Okay, so I need to implement mempty. So mempty is just the empty position. And mappend, I think. We'll do this of pos xy. How does mappend work? Yeah, I'm just going to look. It takes two positions and returns a new one. Okay, so the initial position, and then we'll have imaginative names here, x prime and y prime. And that's going to be a new position of x plus x prime and y plus y prime. Okay. So in theory then I can say something like, can you do that? I don't know. We're just going to say we'll join whatever P is with moving it forward by X and not changing the depth. Okay, and then if we move P where we go down X, this use of mappend doesn't feel right to me, it just feels really awkward. So we're going to do it for 0 and X, and then move P of X is P mappend 0 and minus X. These are all positions. No instance for semi position arising for superclass of an instance. So can I swap out mappend for that? No, I think I might need to implement the semigroup as well. And in this case, I think I just implement that. Perhaps I meant semigroup. Yes, okay. So that, and then we'll just grab, oops. Grab that, we'll just pop it in there. And, oops. Do that. Okay, and then the appends. We can just replace with that. Okay, so what I'm thinking now is if we call move, we give it an a starting position, we give it command, which can be forward, up, and down. It returns a new position by just using really the semigroup instance in this case, by using this operator to join the previous position and the new one, and all it does is sum them together. Okay, so that defines how we move. What we now need to do is convert a single string into a command, I guess. So let's just call this parse command. I guess I could go and grab megaparsec, but it seems a bit of an overkill, given that we just split it on the word. So we're going to go string to command, and then parse command of s is equal to, so we're going to call words on s, and then we'll say case words of, and then if it's a pair containing forward, and then some value x, we're going to return the command forward x, and then we'll have down x is down of x, and up, x is up x. Okay, we have a problem because words will not return a tuple like this. It'll actually return a list. So we can go to there. Okay, I'm going to say otherwise is undefined. Don't use otherwise, use underscore. Okay, so we can't use x here because this is still a string, so we'll call read and that should convert it back into a number. Okay, so now what do we do with our x's? How do we actually do this? If I call, we can call map because we're on the list here. So we can call map parse command of x's. Okay, so now we've turned our list of strings into a list of commands. And then I think we can just call foldle. What's the list of arguments here? So it's move mmd not. So if I just change this for a second, rather than going to an int, if I go to a position. Mechanical, except I can't show the position, but this folder does what I want. So we want to go to an end. So how do we do that? We will we'll just quickly write multiply. Multiply. I could write, it's a bit nasty actually, I could write something on the position. So I could say instance position instance show of position, where show of pos xy is show of x times y. This is a bit nasty. I'm not sure I like this, but it should kind of work, I think. Interested to see if it does. Okay, so in theory, if I just grab these, okay, so let's say run Haskell that. Oh, so I don't save it. No, I did save it. What's its problem? Why is it still saying 0? Like I haven't given it any lines. Yeah, it's still saying 0. That's really weird. Okay. A bit of a problem where whatever this file is not being saved where I think it is. Wow. So I can write the Haskell, but I can't actually just create a file on a disk. It's clearly beyond me. No, that's got the old definition. Okay, I'm going to create a new file. In here, and I'm going to call it main2.hs. Just paste everything into there. Okay, the problem, where am I? This is home John Haskell to main2. Oh, for goodness sake. I'm so shit at just creating files. Okay, copy all that, close it, and let's go to this the hard way. Go to main. Okay, I think we're good. That looks better. Okay, so now if I grab those lines again, if I just do run Haskell main, that's better. Okay, so in theory I can paste into there. And give me 150, which I think is the right answer. So it gives the answer 150. Okay, so possibly not the simplest solution, but kind of fun. I don't know about this returning position and calling show in it and doing the multiplication, because it feels like it should like just derive show, and then I'll write. Oops. I'll write a new thing which converts a position to string. So I might just call this multiply position. Let's go from position there. A position to an int. Multiply pos of x, y is equal to x times y. We'll do this back to an int, and then we will do multiply pos of those things. And in theory, if I just grab this again, it's still 150. Okay, cool. Right, if I go and grab the file now, yeah, maybe we should save that. So can we go, what was it? WSL $. Is this not going to work? Oh, I thought it was going to work earlier. Example file and input file and reference file away. Yeah, I was just a bit lazy with the example file. Args is get args. Oh, I see. So you're asking it which file are you passing in? Which file? So I'll try and save this, and then I'll come back and look at interact. Because I saw Sodling using it, I think. Where are we? This one. Save. Okay, so we should have an input.txt now. Let's see if we do. Look at that, I saved input.zoom identifier. What the fuck have I done? So input is the thing that I want. Input. Wow. It might be trying to write some metadata actually, and it's gone funny when I put it onto WSL. Okay, so I do run Haskell main and just pipe in input. I'm just going to grab that number, see if it works, and then I really will come back and look at interact. Where are we? Here, go back here, drop in our answer. That is correct. Ooh, we got a gold star. Okay, so before I read that, let's go back here and let's look at GHCI. So have a look at interact. So what it does is it takes a function which is given a string and returns a string, and then it runs under IO for you, which means that you can just sort of redirect shit in. It just basically reads all the std in, gives it to your function, and then just prints out whatever your function returns. I think, I don't know if you can see the source of this easily, but oops. No, it doesn't show you that. I think the implementation is actually really simple. So interacts. If you can see the source, it is. So it just yeah, it just pulls all of the content in, calls f on it, so f is the function we pass in, and then prints it out again. So what I'm basically doing for all of these examples is I have this kind of standard interact, and then the function is going to be read the input, break into lines, because we almost always want an array of stuff. Sometimes I might have an fmap read here. Not in this case because we're reading it into strings, but if it was, you could do something really weird actually by deriving position, so you wouldn't have to call, so you wouldn't derive position, you would implement the type class for read, so you wouldn't have to call parse command, we could just get the read to work for that, where this is the implementation of read. But I'm not going to do that, I don't think. I'm going to do that. I'm obviously going to do that now because it sounds stupid. So we got this command. So I think what we can do here is say something. Let me just go to that second. I think I can say instance read command where, and then we can say something like read equals s. Read is not a visible method. Read, what's it called? I believe this is a very bad thing to do and you should never do it. For either reads prec or read.read prec. Okay, what's reads prec? No. Okay, I'm going to back out of this because actually I don't know what I'm doing. Then I'm going to do the next challenge. But I'm kind of now background curious as to whether or not I'm able, to have the fmap read convert the input of strings into. Sorry. It's always important to tidy your code up. I could take this input of a list of strings, or like a single string, and just use read to turn it into a command. But I'm not sure it's going to work, or I don't know how to do it. Actually, I'm sure it would work. Okay, so this is how we solve part 1. Let's have a look at solving part 2. Okay, Planck work doesn't seem to make any sense. You discovered the process is actually somewhat complicated. Okay. You need to track a third value, aim, which starts at 0. The commands mean something different. So down x increases your aim, up x increases your aim, and forward x. Okay, so it moves you forward and then either up or down. So I guess this is the submarine. So it's up and down or tilting the submarine, and then forward is moving at that kind of thing, which explains the multiplication thing earlier, I suppose. Okay. So down means aiming positive direction. Okay, so forward 5 adds 5 to your thing, total 5 because your aim is 0, does not change your depth. Down adds 5 to your aim. So your aim is now 5. Forward 8 moves your horizontal to 13, and then your depth to 40, so 8 times 5, and up changes that. Okay, So with the original input, we now expect to be a position of horizontal position of 15 and a depth of 9, and then it still does the multiplication for some reason. Okay. So I'm not sure solve. It's annoying because I'll need to change my implementation of some stuff a little bit. And I don't want to lose part 1, so let's just copy it. Create a new file called main2. This will be the second part. Okay, so position. Let's create some type aliases. So we got hpos, or let's call it horizontal. Is an int, and type aim is also an int. Okay, so position is now a mixture of horizontal and aim. Okay, so now we're gonna have to look at this whole thing actually, because I don't think this is correct. Oh, we also need depth. Sorry, we need 3 things. So we'll have depth and aim. Okay, because of that, let me do it in the original file. So, horizontal is an int. Depth is an int, and type aim is an int. Can I make this fit into one file? What I was thinking is if I set the aim to be 1, or even 0 actually, oh no, that won't work at all. No, I'm gonna have to do a new file because there's no way I can see of setting the aim to anything particular. It'll preserve the behavior of the previous one. Okay, so depth is an int. So we'll give this a depth as well. And just fix type errors and we're done. Okay, so it's horizontal, depth, and aim. And the initial one is all going to be zeros. Okay, so do we add positions together? I don't think we do. D prime, A prime. Let's put this to undefined for a second. I'm not even sure if my semi-group approach will work. Because what do we want to end up with? We want to end up with forward will not modify the aim or the depth. Down does not modify horizontal or the depth, but it will modify the aim. Okay, so how are we going to join these things together? Because what I've done is I treat a position as a monoid, and say you take a position and you join it to a new position, and it gives you the final position. And I don't think that's how this works anymore. Yeah, forward does modify the horizontal and the depth. I think this is why the monoid approach doesn't work, because this representation of forward is not correct. It's not meaningful in any way. In fact, none of these would ever modify the depth directly, but the depth would be modified when you get it back. So I don't think the semigroup approach is correct here. Okay. Yeah, because you're not taking positions and joining them, which is what I could do before. You're taking a position and a command, and creating a position. Okay, so in this case, I will just do the thing I was trying to avoid doing before, but I'll destructure these, which means that I'm gonna get rid of this. The data position is that. Not data, sorry, type. And we won't derive show from it. Okay, so it's just a tuple now. So position is your horizontal position, your current depth, and your current aim. Okay, and then in here we'll destructure it. So we'll have horizontal, depth, and aim. And moving forward by some x. So we'll ditch the semigroup stuff, and we will say it's going to be a new position, right? So the horizontal position moves by x, and the depth, you are now going to be, is it this value, the new horizontal position, multiplied by the aim? I'm just going to look it up and see that's what it said. So for that 8 to your position, giving you a total of 13, because your aim is 5, your depth increases by 8. So that's the amount moving forward by, times your aim. Okay, that's good. So it's going to be D plus and then H times A. Yes, thank you. Oh, not H. Yeah, it is H. No, it's not. It's X. The amount you're moving. Sorry, not your previous position. You're correct. Okay, and then the aim is unmodified. Okay, so HDA, we're going to move down. So this doesn't move the H or the D, so you're not moving forward or down, but it's going to be A plus X. Destructure again, HDA, and this is going to be HDA minus X. Okay. And the final answer, just check this, but in the final answer, they're multiplying their horizontal by their depth. Okay. So we don't have M empty, but you know, it's just going to be 0, 0, 0. Okay. That was a bit of a mess. I've misspelled A minus X. I've misspelled it, yep. There. Don't know why I ended up with so many characters there, that's right. Done. Yes, sorry. So that will decrease this aim. Okay. Drop my input again. We're running main 2. Can we just paste that in? 900, and it should be 900. Okay. So I run this. It gives me this answer. I can grab that without a return. Okay, let's see if this is correct. Cool, I get a gold star. Good stuff. So that was a little bit messy because I started off with the semi-group approach, thinking that we go basically we have a starting position. We have the position we would be in if we only had the single command forward, up or down, and then we join them together and we get the resulting position. But I can't apply that easily to this case where, I mean, I could write the semi-group implementation, but it would be really weird. Because you're not really joining it to a new command, you're joining it to an instruction to move somewhere. Is there a way that... There is a way of doing this in one file. Okay, so I might go back and do that because I've got a few minutes left. Because if A is 0, oh no, it doesn't work, sorry. If A is set to 0, then this is okay. Like, it just moves you forward. But this up and down would not work. No, okay, so I don't think I can have a single implementation that supports both. It's not one I can see. Okay. Not in love with this solution. I'm not entirely sure what I'll do differently though. I mean, this stuff is all standard. We've only really implemented move. I mean, that's the guts of it. And then the rest of it was just, I don't know, I just don't like this. I don't like the fact I have to destructure everything, particularly things that aren't changing. Could do it with a record. What would it look like with a record? I mean, it'd be slightly shorter, I guess. So, data position of pos. So horizontal is an int. Depth is an int. And aim is an int. This is just overdone. Oh no, lowercase all the same thing. Not what I wanted at all. Okay, so here we could write this as being just call this P. And then this would be P where, what's it called, horizontal? Is that, oops, depth is that, and A is unmodified, so I'm not going to mention it. Oh my goodness. This is horrible. So it actually have to be horizontal of A. Oh, sorry, horizontal of P. Try to do P. Horizontal of P. And we don't have depth. This would be depth of P. We don't have A. This would be aim of P. Okay, what's the complaint about here? So it doesn't like the bracket. Is there an error? Yes. I've typed with horizontal somewhere. I want a T in horizontal, does it? Pedantic. Okay, so do that. That. And that. Is this getting any better? No. I don't think it is. It's just getting too long. I kind of like the idea that you're making it clear that you're saying the horizontal thing. You don't just have these bunch of HDs and A's. But at the same time, this horizontal equals horizontal P plus X is a little bit long for my liking. These are already, well, they're integers, so they're already semigroups and monoids. So could I do something? Well, not really, no. I could write a semigroup instance on this record. So I could maybe join it with X. But I don't think that's going to be better. I think it's just, I'm just moving the complexity somewhere else. So instance, we'll do semigroup. Oops. Position where, see, we're not giving it, we shouldn't really give it a new position like this. It just doesn't feel right. Can we express forward as a combination of expressions? So it's not always one expression. That's an interesting idea. Okay, so let me go back to my original. Just use a triple. Oh, tuple there. Can I go back to where we were? No, I cannot. Okay. My history's messed up. So the data position, these things, let's just make them all ints for a second. I need to say pos. Oh no, sorry, it's back to be type. Okay. So, can I make it a combination of expressions? So if we do like a forward, which takes a starting position and some scalar that we're moving by, gives us back a new position. So forward px is equal to, we'll destructure the p, I guess. So we get h, d, and a, and it gives us back h plus x, d and a. and dive takes a position and an int and gives it back a new position. So dive, and again we'll destructure it, h, d and a and an x. It gives us back h, and then what's this, d plus x times a on the original a. So then forward oh, that's really annoying. Is yeah, I need that x. That's going to really annoy me. So it's basically forward p x followed by dive px. Okay, I'm not going to pull it in scope. I'm going to write it the other way around. So dive. Doesn't matter if you're around we do it. It doesn't, does it? Okay. Really annoying. Okay, we're going to move around. Just swap the arguments here. Okay, so we get forward x of dive xp. Okay. That's definitely better. I think I like that more than the previous thing. If we don't take an int, but we take a... What I'm thinking is, I'd really like to just say... I want to end up with forward followed by dive. I'd like that. And then just get rid of this for a second. Maybe put a guard in and say if it's forward, then the definition is forward followed by dive. But these arguments are wrong. I can't really make them line up easily, I don't think. So I'm going to suffer the indignity of writing this. All right, I was right a minute ago. So we move forward x of dive x of b. All right, slightly better. I guess you could split these out as well, but I'm not sure it's really worth it. Does it work actually? That's another thing. Yeah, it's still giving the same answer, so that's cool. Yeah, I find it really annoying that I'm repeating these things but not modifying them. And it kind of annoys me here as well, but it's hidden away, so it's better. I wonder as well if I can use a folder and then swap these arguments around. Oops. Folder map. Who's used folder map? Is it? Fuse folder map. Oh, yeah, that would work. Okay. I'm going to run through the list once. Of x's. Then we can just either reduce that if we get rid of the other errors. Okay. So these two lines are now wrong. Oh, that's there. Paste in. Okay. So we could do that, I guess. Why would I want to do that? One reason was to switch to folder. Yeah, I'm not sure I'm going to get much nicer than that, to be honest. I think having gone down this route, no, I can maybe make these names a bit nicer or something, but I'm not really going to get it much better than this. Okay, cool. Submarine currying, yeah. I can't really curry my submarine, annoyingly. Oh, do you know what? I'm going to curry my submarine. Fuck it. So, aim up goes int to position so aim up x h dA is h dA plus x, and aim down is int position. So aim down of x h dA is, see if I can get it right this time, so h d and a minus x. So you say aim down. Oh god, I got these wrong. So down increases this and up decreases it. So you can say this okay, so this would be aim up P. Sorry, XP. Okay, and then in theory I can do this. And that doesn't work, but this will, oh, that means bracket it, cool. Okay, so we've curried our submarine a little bit. And then here, we could position that, and then do that. And then we can introduce it, thank you. And then here we can say, show multiply pass of that. There we go. No better, but I've had a bit of fun moving code around. Cool. I think that's it. I'm going to stop at that point because I'm not improving anything. I'm just moving code, but it's great, isn't it? It works. I guess that's the key thing. Oh, I got the answer back. It no longer works. I've done something wrong. What's gone wrong? Well, that's awkward. Why does this no longer work? Oh, okay, so my move to folder is not free. Oh, what have I done? Move to folder will go to the ender list and evaluate it backwards. So it will basically be, if you started at 000, but you did your route in reverse, where would you get to? And that's not the same thing. So it's like a foldable. Oh no. Yeah, that's awkward. Let's go up for a second. So move that, and we're going to apply it to what was our thing called? Like parse command. So I'm going to put my x's back in here again. And x's, oh, but we don't do that, we map it, that's why. Let's use a different syntax just for fun. No, let's not, because that didn't work. So, yeah, map that. The move is now the wrong way around. Oh, that's just nasty. So can I reduce this? No, I can't. I don't think. Look at that. Okay. Yeah, it's the right answer again. So I do need to left fold it. Right folding it is not the correct thing. Yeah, still not wonderful, but yeah, it's cool. Okay, thanks for watching and for pointing out mistakes and for suggesting better ways of doing it. It's been kind of fun. Next week we'll come back and we should be on, I guess, number 9, which is probably going to be more difficult, but cool. All right, I shall see you next week. Goodbye.